Hi, I'm Dr. Alexander NGENZI from University of Rwanda College of Science and Technology, a Department of Computer and Software Engineering. Good morning, everyone. Today, we are going to begin with our first chapter. Of course, it is on DSP, which means digital signal processing. So our first chapter is going to be introduction to digital signal processing. And here we are going to discuss word per word. So it is going to be 3 words, D, S, P. So we are going to discuss each and every word and see what it means and see the importance of each and every word and why do we require this and where does it get applied to real world. When, for example, you go out, then you are being asked what is this and this and this. For example, if they ask you what is DSP, or for example, what is digital, what is processing, what is signal, all those words should be understood in real world examples. For example, what is a signal? As I'm saying, you can hear my voice, that is also a voice signal. There is electrical signal, there is so all those ones we are going to discuss one by one. So today we are going to discuss, of course, the introduction to DSP. So first of all, I'm going to begin with description of each and every word here. D, S, P. So digital. So we are going to begin, but in the introduction part of our chapter, I wanted to let you know, to give you the highlights of each and every point here. First of all, we shall discuss with the definitions, the revision on signals and systems. We will also discuss about the limitations of analog. Of course, we will be comparing the analog and digital signal processing. So we will see the limitations of analog signal processing. We will also discuss about the advantage of digital signal processing, advantage and disadvantage, or pros and cons of digital signal processing. We also discuss the main structure or the main application of DSP. We also discuss the basic elements of DSP. We will talk about the sampling systems. We will also discuss about discrete time signal representations. Again, there are also common discrete time signals. We shall see why are we talking time signals or discrete signals or continuous signals. All those terms we are going to describe them in details. We're also going to discuss the manipulation of this digital time signal. How do we manipulate the discrete time signals? And how, for example, how do we compare the discrete time systems with their classifications? We also discuss the analysis of linear time invariant, because we are going to see the LTI, which means the linear time invariant systems. As I told you, we are going to discuss, for example, here, see digital signal and processing. So, and here, for example, if, for example, we want to explore why do we need DSP? Those are definitions. So we describe the DSP as any manipulation or calculation, or it is any manipulation any manipulations on varying or variable varying information. So there is manipulation varying information. So here you are going to manipulate, but of course you are manipulating what we call an information. Of course, the information should be in digital. And why do you want to manipulate or trying to make the signal more conducive, or to be transformed or to be transferred from one destination to another? So here you are going to pass through these stages. First of all, number one, you have to convey that information, the manipulated information here. You also have to display. You convey, you display, and then after this, then you calculate or you manipulate. So the signal to be purely DSP or to be processed should pass through these stages, so that the signal is being conveyed today from source to destination. And coming back to what is DSP, as I promised here, we are going to talk about the digital signal processing in full. As I mentioned, the D stands for digital, the S stands for signal, and the P stands for processing. So the digital, now we have begun now with we are going to begin with digital, or what does it mean when somebody asks you what is a digital, and how can we put it in a real world examples. For example, when we were studying in our primary levels, we used to count numbers from 1 to 10, for example. But for example, if those are what we call digits, so of course it is from digits. So the digits can count for any number that can be countable. That is from, for example, 0, 1 up to any number, to infinity, for example, Here, if we talk about the DSP here, we are, the digital itself, we are talking into numbers. So the presentation of all those numbers, this is why we call it digits. But here we are considering binary numbers. When we talk of digital, we are considering only zeros and ones, which are called also binary digits or binary numbers. Binary numbers. Why are we considering these digital numbers? I mean binary numbers. You know, nowadays the technology is almost has almost advanced a lot, and you can see most of us, we are using all these devices that are more technological. For example, computer, telephones or mobile phones. All these are using this type of zeros and ones. So the information is considered digital when it is in binary numbers. And why do we use this? We shall see it later. Why do we need digital? Because there were some other information, for example, the analog signals, where we don't even require to put into these numbers. So the digital presentation by a sequence of numbers or symbols being used by processors to analyze, modify, extract information from signals is what we call DSP. So we first of all deal with digital numbers. Then, as I said, you are displaying them. You are going to display them in sequence of numbers. In sequence of numbers, that is, those are binary numbers. They can also be interpreted into symbols. For example, if you say symbol A or B, this one can be converted into digital so that our devices is going to convert all these numbers. We call it a processor. It's going to process the information. And then after being processed, it's going to be analyzed, and then modified. And then after being modified, then the signal is extracted as digital signal. You extract the signal into purely digital signal, and then the whole system is going to be the digital system or digital signal processing, and this is the definition of this word, the entire word. So I hope you understand this. So any question about the definition, you will have to send through my email, and you will just have to. It's going to be shown on my link or the YouTube channel that I will be requiring for you to be sharing, subscribing first, sharing, and likes also are very important, so that you will be seeing the information once I upload my information. So my email is going to be SA. This is the university email, NGENZI at ur@sc.rw, and my personal email is y.genzi@7@gmail.com. So these are the communication channel that we are going to use if any query or any information that you want me to clarify where you didn't understand, and any complement or supplement, or any contribution or any new ideas about the course, so that information can be, the course can be very interactive to all of us. Remember, the main contribution, I myself, is that we want to make sure that the people can be familiar with these online courses, so that it can be there. If everyone can check wherever he has time, or he can just take it when when there is a need. For example, not every time that he has to check, but he can, when he is free, he can just check information, and that information should be useful to him or her anytime. So, my dear students, for example, if you are there, for example, you can check and recheck and recheck again, and this is the importance of this. Whereas in face-to-face classes, when I explain, that one is over, and then you will meet the next session. So this session will be continuous there at your link or the YouTube. So remember to subscribe and share and also likes, so that every time when I upload, you will be seeing what I have uploaded and what was the last session. So that was definition, and this is the communication, where you will be passing the queries information. In case if you want to get full notes, you can get them through my emails that I have shown you. Yeah. So next we are going to see what is the ingredients, or what is the components that we can find in transferring or transforming information here. For example, if we want to transform information from source to destination, so what is in between here? So we are going to see how information can be taken from source to destination using this signal processing, and all transformation and manipulations of the signal. Remember, the signal in a form. For example, if it is an analog signal, one line in the same way like this, if it is an analog signal, it has to be converted. For example, analog to digital converter. We are going to use this one, so that we can get the destination free from analog signal, which may come with distortion, noise, degradations, and some other inconveniences that may make your information to be transferred from source to destination. So you can use, for example, analog to digital converter. If you want to bring it again here, if you want to take it again, you can get digital to analog converter. These are the main transformations that we need. And also here we manipulate. How do we manipulate the transformed signal? For example, taking it into account using these converters. We can also manipulate by filtering, for example. We can filter the signal, the noise signal, to get pure signals. And here, for example, here you can use filtering, for example. Filtering. This one is also common. We can also use. Let me continue this in this way. We can also use compressing the signal, or or the other way around, compressing or decompressing, compressing the signal. So here the reason why we are using compressing signal, sometimes, for example, if the signal is stored in the any storage media, it may be very huge. It can be very huge to the extent that you cannot scrutinize or just make them. It cannot be easily manipulated. So to manipulate it and just put it separate, and also for the storage purpose, you have to compress it. And the other way around, you can use the opposite when you want to return the signal into normal situation. So we have filtering, we have compressing the signal or decompressing the signal. We can also have encoding and decoding, of course, encoding and decoding. In encoding and decoding, for example, if a signal is for example in an analog, you want to make it, for example, using sampling as we'll be seeing it, you make the order of the numbers, the binary numbers we have been talking about, then you put into the decoder, which is going to arrange them according to the system, and then the signal can be transferred from source to destination, as I said from the beginning here. After that, when the signal is put into the system, it has to be analyzed and presented in the normal way. So, for example, if the signal, let me use this. If the signal has gone into various process, for example, if it has been shown, for example, passing through device here, for example, and then into discrete signal, before it was an analog, pure analog or continuous signal, for example, then you end up getting this signal, and then it can be analyzed depending to which form or format you want to be represented, or how you want your signal to be represented. For example, you need, for example, say number 1, 2, 3, 4, 5. So in this way, or you can require, for example, in two binary numbers. For example, you say this is number 1, so you go like this. For example, it goes in this way, so in this way. So it depends. And here, sometimes if you want, for example, to get rid of these noise distortions or crosstalks or any unwanted signal here, you will have to use some sampling system to get rid of these ones, and also get the pure signal. For example, here you may decide to remove all these ones. Then you go like this. Then you can take this signal in this normal way. So the other one that you have sampled, for example, in this case, you find it unnecessary, and then you get after conversion, then you get a signal in this 1010. So this number can be well recognized depending to which numbering system you are using. You may use, for example, hexadecimal numbers. You may use binary numbers. You may use some ASCII coding, for example, ASCII numbers. So it depends. So here it will depend to which value you want to get, for example. So here you can see I have totally got the pure signal, which was taken from, for example, my voice signal. If, for example, I say then the voice signal, for example, is going to the device or the system itself, is going to convert it into numbers, and then these numbers can be well represented when you are giving output. And reason being that our device is going to use digital signal, for example, computer or mobile phones. That's why we need all these numbers in the end, so that these numbers are going to be used in our system, so that the system is going to interpret it easily, because the analog signal can be hardly be interpreted. So, and these numbers also can be turned into text. The speech that I'm giving now can be converted to the text. Then, for example, if I say, then the decoder can be writing some according to the voice that I have released. Then the decoder or any system, the text decoder or conversion can read what I'm talking about. For example, you have been seeing the narrator on the computer. When you say, it is displayed on the computer. For example, if my English is poor, then it is hard as a vernacular language, because it is not in such a way that people can understand, for example. So the narrator is going to put it in the way how it understands it. So those are the speech to speeches to text conversion. So we convert these numbers. I mean, this speech or my voice is going to be converted into numbers so that the system can understand. And I mean, that is the complete definition of DSP, and looking into the D as a digital, looking into signal and processing. So now we are going to go into deep. What are the terminologies that we are using here? What are the great terms that we use in digital signal processing? First of all, we will have to understand from the beginning what is a signal. As I a little bit mentioned earlier, you will also have to understand what is a signal, what is a system, and what do you understand by processing, because these are the keywords. Processing. So these are the keywords that we use in DSP. And what is a signal? A signal, as I speak, that is a signal also. So if I release my words, it's going to be decoded somewhere in terms of signal. But when you are seeing me, you can't easily recognize what is going to be displayed there. So, for example, if I say, it will come as an analog signal, for example, like this. The wandering signal, for example, be displayed there. So that is a signal. So it can be defined as a physical quantity that varies with time, because the time or the seconds that I'm using, for example, here, will determine how the signal. For example, if I speak loudly or fast, for example, I say yeah, ha, 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 like that, then the signal may change in this. So it depends on the time. For example, the signal will vary according to the time here. So also sometimes with amplitude, the magnitude of or the size of the signal. For example, if I'm opening my mouse, it may be smaller, for example, for any other device, for example, which has a bigger size than my mouse. So it is called a physical quantity because you can easily, it is tangible and it varies with time. It can vary with time, of course. Signal can vary with time, and also it can vary with space. For example, the signal from the space, if you are using, for example, the radar system, you can easily determine what is it using the space, but also you can use the time as I demonstrated. And this time and this signal can be independent or it can be independent variables or invariables. For example, it can depend on any amplitude, so that is the time time with amplitude, but also it cannot have, for example, it can go, for example, the continuous signal without having any size. It can also, in variables, for example, having different variables. For example, the values can differ, for example. So, okay, it can take different shapes, for example, in variables. So it can take it into, for example, it can move like this, then it can move into this, then it goes like this, then it differs. So it is harder for you to determine the sequence of varying signal. So that is what we call invariable signals, where you're conveying the information. Here also, that is the definition of signal. A signal is a physical quantity that can vary with time, space, and or any other independent variables or invariable signal which is used to convey information. So, and information, we said from the beginning that information here we are talking about the digital information, the zeros and ones. So any information other than that one is going to be converted into digital signal as an information, so that the information can be free from noise or crosstalks or any other hindrances that may make your signal not be conveyed as it should be. So that is a definition from the signal. Now signal is over. So we can say, for example, then we talk about the system itself. The system. Even this room is a system. It is a system comprising of so many quantities of components. For example, the books, as you can see there, the whiteboard, the chairs, all those so anything that is it's a device, it's a physical or this physical system that can perform, for example, in numerous or in various entities. For example, in this time, it can be defined as a device which can be used to operate many signal. A signal in a different level, for example. So it is also a physical device used to operate or to perform operations on a signal. So first of all, we have seen that a signal is a physical quantity which can be varying or independently or in variables according to the information that can be sent. But also we are going to see a device which performs all these operations that are being acted upon this signal. So this is what we call a system. And for example, as we said from the beginning, the operations that can be done, for example, you remember when we are talking about the filtering system. This is a system on itself. So the filtering is going to filter out the necessary noise and remain with the pure noise that we require for sending our information here. And this is a system. And we can also talk about the processing. So we have talked about the signal, the system. Now we are going to talk about the processing. So after having undergone different operations on a signal, just sampling, just making them into pieces, or just putting them aside, or encoding and decoding, all those stages, then you are going to do some operation performed by the system on the signal. So for example, you are going to use the processor itself, which is going to process the other information, various information that we need to interpret them, then get displayed. So the processor is going to work on this. Of course, the processor will determine, let me give you an example. For example, if it is a computer processor, it's going to process the AC signal, which is analog signal, alternating current, for example, coming from the normal power, is going to be converted, because that signal is not wanted by the device. It has to convert it into digital numbers so that the system can understand. Therefore, it has converted. So the processor is going to process binary numbers.